Today we're going to talk about combinations of functions, how to add them, subtract them, multiply, and divide them, and then we'll learn something called the composition function. So if you're given two functions, f of x and g of x, you can perform the four basic operations. You can add them, subtract them, multiply them, and divide them. So let's see what that looks like. To add them, you would have f plus g of x. That means you would take your entire f function and add your entire g function, and of course simplify by combining like terms. We could do subtraction, f minus g of x. That means you take your entire f function and subtract off your entire g function. Notice you're subtracting off your entire g function, which means you will need to subtract off each of the pieces. Don't forget to distribute that negative. You can multiply them. F times g at x would be your entire f function times your entire g function. Make sure you do any necessary distributing. And we can divide them. F over g of x would take your entire f function divided by your entire g function. Now remember, we have restrictions on division. We're not allowed to divide by 0, so we need to make sure that we remove any x values that would cause the denominator to be equal to 0. G of x cannot be equal to 0. So let's look at an example. Let's suppose we have these two functions, f of x equals x squared minus 1, and g of x equals 3x plus 6. Let's start evaluating some things. So first we'll do f plus g of x, which if you recall, that means we're going to take our entire f function and add our entire g function. So right here, now when you do this, when you do function evaluation, I strongly encourage you to keep your functions in parentheses. Notice I kept f of x completely in parentheses and g of x completely in parentheses. That way you can do any necessary distributing. As you can see here, we don't have anything to distribute here or here, so we can drop those parentheses, and then it's just a matter of combining like terms. X squared plus 3x plus 5. We could subtract them. Now order definitely matters when it comes to subtracting. So notice we're doing g minus f of x, which means we're going to take our entire g function and subtract off our entire f function. And again, keep your functions in parentheses to make sure you do any necessary distributing. Here we're subtracting off f of x, which means we need to subtract off the entire function. Subtract x squared and subtract that negative 1. You need to distribute that negative. And then combine like terms, negative x squared plus 3x plus 7. Let's do it the other way. Let's do f minus g of x, just so you can see how they really do make a difference, which one comes first. So f minus g of x means we'll take our entire f function and subtract off our entire g function. Again, remember to keep your functions in parentheses. Notice you need to distribute that negative. You need to subtract off each of the pieces, the 3x and the 6. Now you can combine like terms for x squared minus 3x minus 7. Notice we get a very different answer than we got when the g came first. So for subtraction, order absolutely matters. We can multiply them. F times g at x means I'll take my entire f function and multiply by my entire g function. Again, keeping our parentheses around our functions. We'll have to distribute. Everybody in the first group gets multiplied to everybody in the second group. So the x squared times 3x, the x squared times 6, the negative 1 times 3x, and the negative 1 times 6. Combine all of our like terms, which we notice we don't have any, so we would just leave our answer like that. It is not necessary for you to factor out the 3, but you're welcome to do so if you choose. We can divide them, g over f of x. Notice g is on top. So I'm going to take my entire g function and divide by my entire f function. Now we have x squared minus 1. Remember, you're not allowed to divide by 0, so we need to make sure that our x values don't cause the denominator to be equal to 0. So, of course, x can't be equal to plus or minus 1, because positive and negative 1 squared minus 1 would give us 0. So that's why we have this little stipulation here. You can add, subtract, multiply, and divide functions for any x, or you can do it for a specific x if you choose. Let's take a look at how that looks. So if you wanted to do f plus g at 3, before when we did it at all x, and now we're doing it for a specific x. So what we're going to do is take our f evaluated at 3 and our g evaluated at 3 and add those two values together. Keep your function evaluation, keep your functions in parentheses to make sure you do any necessary distributing. So f at 3 will replace x with 3 into f. G at 3 will replace x with 3 in g of x. and follow your simple order of operations. Parentheses first. 3 squared is 9 minus 1. 3 times 3 is 9 plus 6. Keeping within the parentheses, we end up with 8 plus 15 for 23. Remember that rule we said before. If you input a variable, you're likely going to get an output of a variable. Here we're inputting a number. Notice we're getting an output of a number. Let's do another example. F minus g at 2. So now we're not doing it for a specific x value, or for the general x value, we're doing it for the specific x value 2. So we'll take f evaluated at 2, g evaluated at 2, and subtract those two values. Keep them in parentheses. Into f we'll replace x with 2. Into g we'll replace x with 2. Order of operations, simplify in your parentheses first. 2 squared is 4. 3 times 2 is 6. Keeping within the parentheses, we get 3 minus 12, or an answer of negative 9. Let's do f over g at negative 2, which means we're going to take our f function evaluated at negative 2, divide that by our g function evaluated at negative 2. Now with fractions, it's always automatically assumed that your numerator is in parentheses and your denominator is in parentheses, so it's unnecessary to put them. So into f, we'll replace x with negative 2. Into g, we'll replace x with negative 2. And then we'll simplify our numerator, simplify our denominator, then divide. We get 4 minus 1 over negative 6 plus 6. 4 minus 1 is 3. Negative 6 plus 6 is 0. Do you notice something that's kind of an issue here? That's right, we can't divide by 0, so we say this is undefined, and that's our final answer there. So, basic operations, adding, subtracting, multiplying, dividing with functions, you can do it for the general x, you can do it for a specific x, you can do it for any input that you want, as long as you don't break one of our rules. Now let's define this other function called the composition function. The composite function is the function f, looks like a little open circle here. It's not the multiplication sign, it's an open circle rather than a closed dot, and then g of x. It kind of looks like it's fog, so maybe you remember learning this in high school called fog. This is read f composed with g of x. And how you define that, this is sticking a function inside a function. F composed with g of x means into f you're going to put the entire g function, f of g of x. So we're evaluating a function at another function. So let's look at an example. Let's say f of x is x squared minus 1, and g of x is 3x plus 6. These look familiar. Let's do f composed with g of x. So f comes first, that's the outside function. G comes after the composite symbol, so that's the inside function. So we're going to evaluate f of g of x. Well, what is g of x? It's 3x plus 6. So into the f function, I'm putting the entire g function, the entire 3x plus 6. F takes whatever's in the parentheses squared minus 1. Whatever the input is squared minus 1. So we'll take whatever's in the parentheses, 3x plus 6, square it, and then subtract 1. Now remember what it means to square something. You're going to have to times it by itself. 3x plus 6 times 3x plus 6. Distribute this out. Everybody in the first group gets multiplied to everybody in the second group. And then we'll combine like terms for a final answer of 9x squared plus 36x plus 35. Now let's do it the other way. Notice this answer. I want to keep that answer in the back of our mind for a second. And now let's switch the order. Let's do g composed with f of x. G is the first function here, that's the outside function. F comes after the composite symbol, so that's the inside function. So we're going to evaluate g at f of x. Remember what f of x was, x squared minus 1. So into g, we're going to put the entire f function. So if you remember, g takes 3 times whatever your input is, plus 6. 3 times whatever's in the parentheses, plus 6. Notice we're going to have to distribute that 3. And then we combine like terms for a final answer of 3x squared plus 3. Now notice the answer we got for A when we did f composed with g, and now we did g composed with f. Two completely different answers. In fact, most of the time when you compose two functions together, you do get two completely different answers. We'll talk in a later section about when you compose two functions each way, it does in fact give you the same answer. There's a special case, and we'll discuss that in a little bit. Let's take two new functions and do another example. We'll take f of x as 2x plus 3. and g of x is 1 minus x squared. Remember your order of operations, exponents come before subtraction, so we're going to square whatever this is before we subtract it. So we'll start by doing f composed with g at x, which is f of g of x. So into f, we'll put the entire g function. F takes 2 times whatever's in the parentheses plus 3. 2 times your entire input plus 3. Distribute that 2, and then we'll combine like terms for a final answer of negative 2x squared plus 5. Now let's do it the other way, g composed with f of x. That means into g we're going to put our entire f function, g of f of x. Remember before that f was 2x plus 3. So g takes 1 minus whatever's in the parentheses squared. 1 minus your input squared. Remember what I said about order of operations, we're going to need to distribute this out here. We're going to have to square this first before we subtract. So we will keep that in parentheses. We'll take that 2x plus 3 times 2x plus 3, and we'll multiply that out completely in parentheses. That helps us remember that we need to subtract this entire product, so we're going to need to subtract each of the pieces. So we distribute that negative. Everybody in here gets the opposite sign. Combine our like terms for negative 4x squared minus 12x minus 8. And again, notice that f composed with g and g composed with f gave us two completely different answers. Now, when we talked about adding, subtracting, multiplying, and dividing functions, we said we could do it for the general x or for specific x's. The same thing goes for composing functions together. You can do it for the general x, like the last few examples we just did, or you can do it for a specific x. For example, let's do f composed with g at negative 2. So now instead of at all x, I want it for the specific x negative 2. So following the same thing, f comes first, it's the outside function. G comes next, it's the inside function. Now we have the specific input of negative 2. So f at g at negative 2. Work your way inside out. The first thing we'll do is figure out what g at negative 2 is. Substituting negative 2 into the g function, we get 1 minus negative 2 squared. Negative 2 squared is 4, and 1 minus 4 is negative 3. So now that's what g at negative 2 is. G at negative 2 evaluates to be negative 3. So into f, we'll put that negative 3. 2 times negative 3 plus 3 gives us negative 3. Let's do another example. Let's do g composed with f at 3. So g is on the outside, f is on the inside, and a specific input of 3. So this is g at whatever f of 3 is. So into f, we'll put in 3 for x. 2 times 3 plus 3 will give us 9. So into f, I want to put in the specific value 9. Into g, I want to put in that specific value 9. G takes 1 minus your input squared, which gives us 1 minus 81, or negative 80. So as you can see, you can do it for the general x, or you can do it for a specific x. In the next section, we're going to talk about composing functions more, about when you compose two functions together, f composed with g and g composed with f, you do in fact get the same value. Until next time, have a good day.